Now, I don't like it whenever the absolute value is on the right-hand side. This bothers me. But if we follow rewrite original, I could just rewrite the original, and then I flip my sign and make negative for the second one. Remember, it breaks into two. So the first one, I just rewrite the original. 12 is less than 3z minus 4. And then for the second one, I have to say negative 12 is greater than. Note, I flipped my sign and I made this negative. I made my value negative. 3z minus 4. Now I add 4 plus 4 plus 4. I can do them both at the same time. I got a lot going on in my life, so I can do that. Plus 4, negative 12, 11, 10, 9, 8. Negative 8 is greater than 3z. We divide by 3. So I have 16 thirds is less than. 16 thirds is less than z. And over here, divide by 3. I have negative 8 thirds is greater than z. Graph that on a number line. Here we go. Bam. Got it. Which one's the smaller one? Well, the negative one obviously is going to be smaller, so negative 8 thirds. I know 0 is there. And then we have 16 thirds. Open or close dots? Open. Nailing it. Now, I need to be very careful as to how I do this. This tells me that z is bigger than 16 thirds. Notice Pac-Man eats the bigger, right? So this one is saying that z is bigger than 16 thirds. Here's 16 thirds, so I shade to the right. This z is smaller. It's on the small side, so z is smaller than negative 8 thirds, meaning I shade to the left of negative 8 thirds. All right, all right. Okay, here we go. Problem number 45. List all the subsets of the set. Now, when it comes to listing subsets, start with the empty set. Whenever I have to list all subsets, first things first, empty set. Then I want to list everything that has one element. So all the subsets that have one element. Well, for this one, I have zebra. That's an element. And then I have lion. That's one element. And then we have tiger. That's one element. Now I'm going to list all the elements that have, or all the subsets that have two elements. So I'm going to go zebra, lion, and then I'm going to say zebra, comma, tiger. And then there's one more. That is my lion and tiger. And then finally, I want to list all those elements. So there's one subset that has all of them in there. And we got zebra, lion, tiger. So note, you always start with the empty set and you end with the full set. Ba-dum-bum-bum. Get it? Full set because it has everything in there? That's not a real term. I just made it up. So you start with empty, and then you list everything that has one, everything that has two, and then all the way until you get to the one where it's full. So we start with the empty, and we end with the full. Just list them out. I'll let 46 and 47 you can do on your own. 48. Here we have 48. The empty set. Well, the only subset of the empty set is the empty set. That's it. There's nothing else inside the empty set, so there's no other subsets that we could possibly create for it. All right. Here I'm going to do 49, 50, 52, and 53. I want to make sure we know unions and intersections really, really well. So before I do too much, I want to make sure we know that this stands for union. And whenever we see that as a Venn diagram, here's my Venn diagram. The union is all of the ones that are in every part of it. That didn't make a whole lot of sense. The union is all of the elements in both of the sets. And then we have the upside down U, which is an intersection. In for intersection, U for union. You're welcome. I gave you a mnemonic device. It's an English word. It's a big one. And here for the intersection, it's just where they intersect. Use the language to your advantage. All right, so for 49, A, union, B. Well, I'm just going to start off by listing everything in A. Well, A is 1, 3, oh, I don't know what that was. 1, 3, 5, 7, 9, and 11. Now I want to go for B. It's a positive odd integer. Positive odd integer less than 10. All right, so I have 1, 3, 5, 7, 9. Those are all the positive odd integers. All of the positive odd integers already. Well, I've already got them all listed, so here you go. A union B. Those are all of the elements that are in A or B. For problem number 50, A union C. All right, well, I'm just going to start off and list everything that I found in A. So that's 1, 3, 5, 7, 9, 11. Now, C is 1, 2, 4, 7, and 9. So what elements in C did I not already list? Kaylee. What elements in C did we not already list? 2 and 4. Rocking it. That's my union. Oh, no. All right, so 52 is A intersection with C. All right, so this is the intersection. That's the one that they have in common. So between A and C, well, there's a 1 in each of them, so I'm going to start with that guy. There's a 1 in both of them. Is there a 3 in both of them? No. 2, no. 4, no. 7, is that in both of them? Yeah, 7 is in both of them. 7 in both of them. 9 in both. Yeah, 9 is in both. 11, no. Okay, so that's my intersection of A and C. Now it wants the intersection of A, B, and C. So for A, intersection with B, intersection with C, I want to list out all of the elements that are in A, B, and C. All right, so B again is the positive odd integer less than 10. So that's 1, 3, 5, 7, and 9. Well, 1, 3, 5, 7, and 9 are already contained in A. So then all I have to really worry about is the intersection of A and C. What? Whoa. Whoa, that was a giant mathematical leap there, Mr. Stevens. Here, let's just go ahead and put B in roster form real quick. It's a positive odd integer less than 10. So that's got to be 1, 3, 5, 7, and 9. Now, I want A, B, and C. I want the common elements from A, B, and C. Well, A, B, and C all have a 1. Do they have a 2? No. Do they all have 3? No. Do they all have a 4? No. Do they all have a 5? A and B do, but C doesn't. What about 7? Yes. 7 is contained in A, B, and C. 9 is contained in A, B, and C. And I don't have to worry about 11 because I know it's not contained in C. So, for A intersection B intersection C, it's going to be 1, 7, and 9. Let me clean that up just because I feel real bad. 1, 7, and 9. All right. I hope you let these reviews help you out through the exam, and good luck.